Yeah, okay, recording start. Okay, so I'll just share my screen today. Yeah. Hello, yeah. Can you see my screen?
Yeah.
Okay, thank you. Well, today we have three problems, one from easy, medium, and the hard bucket. So I will start with the first one, which is the easy one. And okay, so the problem statement for the first one is self-dividing numbers. And the definition for self-dividing number is a number that is divisible by every digit it contains is self-dividing number. Okay, for example, if we have the way it says 128, okay, if we take each of these digits like 1, 2, and 8, and they can divide this number 128, so it means 128 is a self-dividing number. And it also says that this self-dividing number cannot have a digit 0 because divided by 0 is going to be an exception. And the problem statement says given a lower and upper bound, we need to find all the numbers lie between the lower and upper bound, including them, and just return the least or vector or array of those numbers. And the boundaries of the left and right bound is stated as it can be minimum starts with 1 and maximum it can be 10,000. Okay, so that is what the whole statement, problem statement is. Like it can start from 1 to 10,000. Okay. So it's very simple, and this is the way the whole uh, problem statement is about this question, the first one. So the way I approached is, I I would try to take each and every digit by taking a mod, the modulo 10 of this number, and then again divide that number, and then try to divide that number and see if it is modulo of that number is equals 0, and then I would say that this number is a self-dividing number and include in my list. So for example, like the first one, if it says the left is 1 and right is 22, right? So we can start from all numbers starting with 1, 2, 3, 4, 5, 6, 7, 8, 9. One digit numbers are self-dividing numbers, so we have to include all of them. So we cannot include 10 because it has 0 in it, right? So if we say the next one is 11, so both the digits of 11 are 1 1, so they can be divided, so it's a self-dividing number, and then 1 2 similar way. So if I have to take something like 1 2, I would actually first do a modulo 10 of it, which will give me 2, right? And then I will use 12 divided by 2. Okay, so 12 modulo 2, if it is equals 0, it means it is it can be divided by 2. And same I'll try with the second digit as the first digit, sorry, like dividing 12 by 10, okay, which will give me 1. Okay, in this case I don't have to do anything, I don't have to do the modulo 10 again. Okay, so it will be 1, and then I just divide this by 1, it will be 0. So I can easily say that this number is a self-dividing number. Okay, I'm just giving an example of how 12 will be, how to find 12 as a self-dividing number, So yeah, so we can keep on doing this, and exactly the way I am saying, I just tried these numbers and I included in the list, and I'm just returning the list. Okay, So there's nothing much to explain in this, but I'll just quickly run through the solution what I've implemented. Uh, it's I'm just taking the left and right over here, okay, and just going through a for loop, and in the for loop I'm actually having this function which decides whether this is a self-dividing number. Okay, I just pass on this I, and if it is a self-dividing number, I just add it to my vector and then return. So this self-dividing number, this function, I've just, the first thing what I've done is I've included all the single digit number. Okay, if it is single digit number, I just return true. If it is modulo 10 equals 0, if it is divisible by 10, I'm saying it's false. Or else actually I go in this while loop, and as I said, I find the last digit of each and every number and first check if it's a 0. If it's 0, I just return false. If it is not 0, then I see if I can divide this number by the digit which I just extracted, and if it is not 0, I return false, and just keep on dividing the number what I've taken earlier by 10, so I can get the next digit. Okay, so this is what the very simple implementation. There might be other approaches also to do this, but I thought this was the easiest way to do it, so I just did that. So any of you guys have any other approaches or want to discuss something, any inputs on this? Highly appreciable.
Like, time complexity should be what here, order of n only. I mean, throughout the list we are going. That's it, right?
Yeah, that is what I think. It should
Or
be
if,
open. Yeah, and yeah. So O of whatever the numbers
n,
are in it, right? Yeah. I'm sorry. Could you go ahead?
I think it should. Somewhere I saw it was like order of n log k, but when they were mentioning that n is the range and k is the maximum number, but I couldn't understand how do they. I mean, how did they get that?
O of log. Okay.
N log k, where k denotes the maximum number and n is the range from left to right.
Mm-hmm.
Think,
General term. Oh no, because if you look at it, I'm going through each and every number, right? So
yeah,
I
that
can
is order.
skip any number. So
Yeah,
I don't understand how it is like a log of k here. Um, yeah, because we are not doing any sort of. It is all anyway. It's nothing to do with the sorting, something like that, or neither is going through a binary search. So
yeah.
I'm not sure about that. And the time
So,
complexity is same, like of whatever the numbers are.
and this while and this will take and like, I mean, we are extracting each digit and running through each of the number, right?
Yeah,
So this will take whatever will be the length of the number.
yeah, the length of how many digits it contains. So maximum it may be like 10 raised to 9. So 9
Uh,
to 10 digits, maximum. So
and this for loop will be order of n. Yeah.
yeah, so it might be a constant in this case because it's just an integer.
Okay.
Yeah, I might be wrong here, but yeah, that is what I'm.
No, yeah, I also couldn't, but I'll check it. Okay. I'll, I'll-
Yeah, yeah. Anyway, this is a very simple problem. I don't think much over here. So is this okay? Anyone has any input before we move to the next one?
it's fine, I think.
Okay. So the next one. Okay. I just stopped the screen. Sorry. One change problem. Okay, so this next problem is about the coin change, and I think we did this one yesterday, right? Yeah,
Yeah.
yeah. So it says you are given coins of different denominations, and the total amount of the money amount, and then you are given an amount also, right? So we need to find like the fewest number of coins that you need to make up that amount. And if that amount of money cannot be made, then we need to return -1. That's the only thing over here. So the first example is of coin denominations. So these are the coins like a 1, 2, 5, and we have amount. So amount is 11, and then if you can see, we can have this with the first coin of denomination 1, we can have 11 such coins, right? And with 2 we can have 2 5s, right?
Yeah.
And 1 1, right? So 5 plus 1, okay. And with the second one, we can have, with the denomination 5, we can have 2 such coins and plus 1, right? So if we see 11, 6, and 3, so 3 is the lowest one, and therefore the answer is 3. Okay, so this is the way uh, the answer would come to. And if the second example, if it says like if the coins are 2 and amount is 3, so the coins denomination is only 1, it's 2. So in this case, if we try to find out, we can take one coin of 2, right? But the remaining amount in this case will be 1. And if we try to come back and see what the coins are, we don't have any coin with denomination 1. And hence we cannot actually satisfy this condition, and therefore we might have to return -1 over here. Okay. And we have to assume that we have infinite number of each kind of coin, so the supply is surplus. Okay, so the way I think Gaurav was discussing yesterday. Okay, so if we take the amount 11 now, and if I have an array something like this, which starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the indexes, okay, of this array. And I have all zeros over here. So I initialize the whole array with first zeros. Okay, so all these zeros over here, and then
maybe initialize to the very big number, because the goal is to find the fewest number of coins.
yeah, that is true. But anytime, that is what I thought of earlier. But when I went through Gaurav's thing, I think we have to go through each and every combination. Sometimes it might so happen the combination might come different. Even if we start with the highest one, it might be the lower, and some higher combination can give you some different results. That is what my thoughts are. But let me start with this first, and then maybe we can work out the way you're saying, Emily.
Okay.
Okay. So the first thing what he said at that time, like if I have this, the first example, okay, right? So I have coin denomination of 1 to 5. So every time I actually come here, okay. So what I need to do for the 0th position, I don't have to do anything, right? I start with the 1 because I have 11 of them, right? So I start with the 1 and just see if this coin denomination 1 is lesser than or equal to this index. So here it is equal, right? So I can actually just add 1 over here because one coin can fit in this one. So then I come to the 2. In this case, what I need to do is I'm still this index 2 is greater than the coin's denomination 1. So I can add 1, but before adding 1, I need to find the previous of that. So 2 minus the coin's denomination is 1. So 1, this position, right? So I'm just coming to the previous one here, 1. So already I have 1 over here, and then I add this 1, right? So the way he was saying yesterday, the formula was something like the dp of, whatever the index, the index, and minus coins of whatever the denomination here is, right? So if I find this and this add 1 with the current one, so here I will get 2, right? So similarly, I come for 3, so I can add 1. This is the one I can add, but I need to go back one step, or the coins denomination, I just subtract from 3, so it is 2. So I go to this index, I see here 2, and then I make this as 3, right? So if I go on increasing the way it is like this, so this will be 5, this will be 6, this will be 7, and this will be 8, 9, and 10, and then 11, right? So but every time when I do, I need to actually check if it is if that is the minimum one, right? Okay, so so now this is the first denomination coin that we completed. Now if I start with the second, okay, so I start with again the first index. So first index 1 is lesser than 2, right? So I can't do anything here. So I go to the second index here, 2, and then I see this 2 is equal to this coin's denomination. Okay, so then I can actually, from here, if I subtract 2, this index 2 minus coin's denomination of 2, it will come to the 0th index over here. So for denomination of coins 2, I will have 1. Okay, so as he said earlier, it was like I need to take minimum of whatever is existing over here, like if this is a DP array, okay, and if it is something like INJ, okay, oh no, it will be only 1. So if I need to take whatever is this minimum of this one. So my year, in this case, the DP of I1 previously was 2, and the current what I'm calculating is 1, right? So I will take the least one, and therefore I will just remove this 2 and make it 1, right? So for the 3 also, I do the same thing. It is 2, I go here, it is 1. So here it will be 2 coins, right? So 4, it will be same, it will be 2 over here. And for 5, it will be 2 plus 1, it will be 3, right? And for this 6 will be 3. And 7 will be like, I go for 2, which is 5, 3, and this will be 4. For 8 will be for 6, 3 plus 4, right? So for 9, it will be 1, and 7, there is 5. And for 10, it will be 1 and 8, that is 5 again. And for 11, it will be 9, that is 5 and 1, 6. Okay, so this is what was for 2. And then now I start with the denomination 5. So I run through the whole array again, and I come to first index. It is lesser than the coin's denomination 5. So I just skip it. I skip 2 also, 3 also, 4 also, 5. And 5 actually is equal to the coin's denomination, right? So here I do the same formula over here. So DP of I this time is 5, right? Oh, sorry, this time is 3. But if I look at the index over here, okay, so the coins will be 1, but 5 minus 5 is 0. So this will be just 1 over here, and therefore this is lesser than this value 3, so it becomes 1. For 6, again I do the same thing. So it is 6 minus 5, which is 1. So 1 plus 1 will be 2, right? For 7, again, I do the same thing. 7 minus 5 will be 2. It is 1. So this will be 2. And for 8, actually, it is again the same. 8 minus 5 will be 3, which is 2, plus 1 will be 3, right? And for 9, 9 minus 5 will be 4, which is 2 plus 1, 3, right? And 10 minus 5 is 1, right? So this will be 2. And for 11, 11 minus 5 is 6, 6 is 2, right? And then 2 plus 1 will be 3. And therefore our answer is 3. Okay, so this is the way I think he also evaluated yesterday. And okay, so our answer is 3 in this case. Okay, so any inputs on this approach, any corrections if someone wants to make for now?
So how do we think this in terms of dynamic programming?
Oh, so this is the way the dynamic programming, what I'm doing. It's a bottom-up approach. So I set an array, like this is an array of index. In this case, the example is of amount 11. So I set an array of 12 elements. Okay, so and these are the indexes. And then I just go through this array each and every time for each and every coin's denomination. Okay, and I'm just filling the values the way I explained just now. So I'm just filling the values starting with the first coin's denomination 1 and then going to 2 and then going to 5.
What at index 0, what does it mean? It
So,
mean like we don't have any coin or?
So it's a 0 is the base case, right? So the base case for this is 0. And therefore I initialize that to 0.
I mean, if amount is also 0 and count is also a number of, I mean, yeah.
Yeah, so the amount is 0, and if the coins are 0, then it will be here, right?
Or either coin is greater than the amount. In that case also, I think it will be 0. Let's say if we have a coin of 10 and amount is 5, it won't work.
Sorry, come again. If we have?
Let's say if I have a coin of denomination 10 rupees coin I have, and the amount is 5.
Amount is 5. Yeah. So in this
So in that case,
will,
yeah.
amount is 5. So in this case, what will happen is, okay. So before, actually, one thing what I should have done is instead of having this to be initialized to 0, it should be initialized to a maximum value. Okay.
Yeah, exactly.
So yeah, so therefore the minimum won't work in that case, right? So I actually should have done instead of 0, all should have been initialized to the maximum value and set the 0th index to 0, because that is the base case. Okay, so now in this one, the coin 10 and amount 5, if we take this example, so amount is 5, so our array size will be only this much, right? So
Yeah,
if I start comparing this amount, okay, so this is always lesser than the coin denomination. So I will have to return -1 because I am not able to do anything in this case.
Okay. So this is one of the base case. It could, no, it can't be base case, but exception. I mean, apart from,
yeah, so
one of the corner cases you can, yeah.
Right. So if I say, this whole array actually I initialize with something, the max value, maybe into max, something like that, right? So for all of them, okay, and then so if I do this, and then I have a base case, I start with 0 over here, okay, and then I'm not able to fulfill this condition of amount 5 and 10 coin, denomination 10. So when I'm actually coming out of the loop, returning, so I will look at the last figure, okay. So the last element of the array, if it is greater than my current amount, so I will say it is -1. I'll just return it -1. Or else if there is some value, I'll just return that value. Okay, so that can be taken care with the -1 actually. I can quickly run through the implementation.
Yeah, sure.
Yeah, so that might slightly be clear.
कुकर बंद कर रहे हैं.
Okay.
आणि भाजी पण माझं भाजी पण चालू आहे.
Can you please mute yourself? Sorry.
Yeah,
Okay.
yeah.
Please. Sorry about that.
Somebody. Yeah.
Yeah. So actually, see, this is the array, right? Okay, I was talking about. This is my whatever the DP or DP array, what I've set for, and I'm setting this is the amount. Okay, I'm just setting this value. This is the element amount plus 1. Okay, so I'm setting this array to a size of amount plus 1, and also I'm setting the value of each and every element to amount plus 1. Instead of going to int max, I'm just using the maximum amount plus 1. Okay, and I'm just setting this as a base condition of dp 0. And then when I go through this whole loop, okay, and when I come to the last point and I see the dp of the amount, that is the last element of this array, if it is greater than amount, then I return -1. You know, so this is what the last case what we were talking about right now, right? So how -1 comes
Yeah.
on, okay, or else I just return the amount. And here, this is what the two for loops are. This actually, the first for loop is for the coins denomination. Therefore, it starts from 0 to m. And the second for loop is actually going through each and every element of that DP array. What we were talking about, just taking each and every coin denomination, if it is greater than or equal to 0, it means like the coin I, if it is greater, if j is greater than coins of I, means the amount is actually greater than or equal to coins of I, then only I come in here and I look at and do the manipulations for this DP array, right? So here actually I just subtract from the j, that is the amount minus coins of I, and just add 1 to it and see which is the minimum. Either the previous element was minimum or this element is minimum, and then again reset that array value. Okay. I think he explained it yesterday also the same way. Yeah.
Yeah.
Well, yeah, little, just little, maybe observation that
Sure.
if on line 64, if we set j equal properly equal coin I, then we don't need to if loop on line 66.
I'm sorry, come again.
If on the for loop, the inner for loop on line 64,
Okay.
if we set j equal coin I, then we can remove the if statement on line 66.
So you are saying here what I should say? J equals
Coin I on line 64.
Oh, you mean to say the initialization portion,
Yeah,
this
yeah,
one?
yeah.
Okay, here I just say coins I.
Yeah. Then we can
Coins
remove
I.
the if statement, right?
Yeah. That optimization can
Small,
surely
yeah.
be done. Yeah.
And my second question is, does the order of coins matter? Do we have to sort it, or it can be, random, can be anything? I
It
mean,
can be
or it can
anything.
be 521 or
Yeah.
152.
Yeah.
It
surely
can be
should work.
anything.
Yeah.
As there's an infinite supply, so you have to emulate all the coins.
Yeah, I know that infinite supply, but the order, do we have to sort them?
No.
We don't require, because whatever the way you do it, it will still come to the same way. Only the readings will be slightly different, but at the end the results will be the same. The intermediate readings will be different. Because
one thing is, if you sort it, like at least if you're trying to trace the diagram, that would be useful. So if you start with 5, you will get to the answer soon. So that is one advantage, that's all, but not the program.
Right.
So my 2 cents just for the DP. So initially, I mean, I would say that if you are just starting the DP, so just start with the top-down approach, and that will help you to actually visualize the solution. Bottom-up is really difficult initially to visualize that. So if you just actually look that problem from top-down approach, it will look super easy to you.
Okay, I have an implementation of the top down. Okay, I can just quickly run through that. But what you say makes sense, absolutely.
Yeah.
I also had that same thing. But yesterday when I attended that session, so I felt, okay, this is slightly much easier the way.
Yeah, I mean,
Once
after
they
after
understand that.
having some solving some problems, so then you can easily visualize that the bottom up.
Correct, correct. Yeah, I
Yeah,
agree.
and one more thing I would like to share here with you guys that I know that, I mean, it should be most of you are actually aware about that, how we actually determine the size for the DP array, whether it's a 1D, 2D, or 3D. So it's all depend on, just think like that, what are your variables?
Mm-hmm.
So here in this case, there is only one variable, the amount. Because if we have the infinite supply for the coin, so that is not the variable. But if for 0 1 knapsack, we know that there is a two variable. One is that if we pick the value, so that we have to change that our inputs change, and the same here. But here in this case only the amount is changing, so that's why we are taking only the one dimension array to keep our state.
Oh yeah, okay, thank you. That's good. Yeah, actually, what you say makes sense. We can also do with the multi, what do you say, 2D array also. I can take all the rows as the coins, denominations, but that's not required. It can be
Yes.
easily done with this one.
Yes.
But for the others, what you say, yeah, we might need those things. And if you have to optimize, then we'll have to look for different ways of optimizing them.
Yeah, this is actually how I think about what should be the size, what should be the dimension. So this is how I think actually, and always the zero is that the same like in recurrence relation. We always have the base case. So here in bottom ups, the first element is first entry is always the base case, like what we have in our recurrence relation.
Yeah. Yeah, that makes sense. Okay, so I'll just quickly run through this, the top-down approach here. Okay, this is the top-down approach. Okay. This one. So I just check for the size of the coins, and then I set a cache or memoization memo over here, which is equal to again the array size of amount plus 1. And then this is the helper function wherein I pass in the coins vector or array, and then the amount value, and then the memo. So this helper function actually it's implemented over here, and so in this actually the base case is I set this is the n, which is the amount which keeps coming over a year, and if this n is less than 0, I return -1, and if it is equal to 0, I return 0. These are the two base cases, and where when the memo has value -1, because I've initialized all memo array to -1. If it is not -1, then I return that value. And this is the for loop where I go through each and every denomination of the coins. And then this is the helper function, which is I called again for same coins, but decreasing the amount here. Okay, so every time when I decrease the amount value over here with the coin denomination, okay, then it goes back over here. If the coin denomination is greater than uh, this one, the amount, then it means it is okay, it can consume them. Or if it is lesser, then actually it returns -1, and that is what the base condition was. Okay, so if this is the helper function, you can check what the value is for the previous ones, and then check if it is greater than or equal to 0, and if it is less than the previous one. That is what the minimum what we are trying to find here. And then we just add that, and then add this to the memo, and then return this memo array. Okay, so this is the top-down approach. So every time whenever you find a coin denomination, we just subtract this from the amount and come back again over here, and then keep continuing for other points till we don't get the optimum value. Okay, so
yeah.
yeah.
I have a question. For this approach,
Okay.
has the same time complexity as the dynamic programming?
I think it should have the same time complexity. It should not be different if it is
Yeah,
top down or bottom up.
yeah, it has the same complexity, and to be clear, that both are the DP approach actually, not that just the one. Just the one is the bottom up, and this one is the top down.
Yeah.
Thank
And
you.
one question is like you're passing amount as amount plus one. So why it is plus one?
Oh yeah, I'm just actually giving some in this case, right?
Yeah,
The DP one or this one?
Yeah, this one, top down.
In the top down, I'm just giving one value more because I have a base case with 0, right? So if I have a base case with 0, so my amount, if it is 11, so I need 12 spaces, right? Including the base case.
Okay, okay.
Yeah. That's what I'm just adding on.
Okay, got it. Yeah, thanks.
Okay, any more questions on this?
With the DP one, the bottom up.
Top down, bottom up. Okay, sorry.
Yeah, bottom up. You see that the deep on line 67. There's a DP 2 dimension, right? You say both amount plus one.
it's not 2D, it's just 1D with,
1D.
and the second parameter is just to initialize that.
Oh, okay.
It's value, right? Yeah.
Got it.
Okay, so shall we move to the next problem?
Yeah.
Okay.
I think we are talking for that as just back for the previous problem.
You mean to say the first problem?
That time complexity I was talking. I think because of that while loop, it will take log of and let's say if I have a number 4, if you divide that number by this while loop, you are dividing this number every time by 10, right?
Right.
So 10 raised to the power 10 raised to the power k. I mean, let's say k times you divide, that should be equal to n. Then k will be, and then I mean n is equal to 10 raised to the power k. Let's say if you take a number 4, if you divide by 2 times, then 2 raised to the power k equal to 4, right?
Okay. Uh-huh.
So here, each time you are dividing this number by 10. For every for loop, you are calling this function, right? This while loop will be called.
Yes.
Yeah. So so order of n and log k, it will take every time for bigger number. Like I mean, in the worst case, they are talking. Like let's say if n is 100, then 100 you'll divide by 10 2 times in order to reach the number 0. So 10 raised to the power k should be. So I think log of k are coming from here. I mean, just a guess here. Kind of.
Okay. Makes sense. Yeah, so you're dividing it, so therefore it will be log, right? Yeah, log of base 2. Yeah, that's right.
Base 10. I think here base 10 because we are dividing by 10.
Yeah, all right. Sorry. Yeah, this is base 10. It's not.
Yeah, had it been 4 dividing by 2, it should be base 2. Yeah.
Can we say that since the integer has a max limit or min limit, can we still say it is bounded by O of n?
That is for the for loop, right? Like from left to right you are going.
No, while loop.
Yeah, we can say that often as the number of digit in an integer is constant.
Yeah, but
it seems there's a limit. Like it's how you represent, like how you want to reason your way through, right?
I think.
Yeah. For this question, maybe I can transform the number to the string and iterate the whole string to get each digit in the number.
Yeah, that's also a nice approach. Converting to a string, and then it will be easier to access the digits rather than dividing it. Yeah. Log k doesn't make much difference also here, I think, but to be a bit precise, I think.
But
So
converting
that
to
by
string
doing by
again
convert,
will be
by con
twice we are doing
yeah.
this, right? If we convert it to string again and then reconverting it back, will that be a two-time operation?
But simply we'll write int and pass
So
that
I
string
think
and then
he's suggesting that to just to convert the number to a string and then get. Oh yeah, you are saying you're right.
yeah,
But
it will be.
it depends on the language that the conversion
Yeah,
will.
that's
So
true.
in C++, it's not required the conversion, but maybe in other language we may need to
Yeah,
In,
makes
require.
sense. Mm.
in Python also within int, if you pass the string, it converts entirely to string. Sorry, integer. I mean, if you convert to a string, this while loop would be eradicated in that case, I think. I mean,
Okay. Yeah,
okay, yeah, we can
no problem.
go ahead.
Yeah, good. Thank you.
Yeah.
Okay, so I'll move to the last problem, the dungeon game. Okay, so this is from the hard bucket. Okay, and the problem statement is it is about a game wherein we have something like a grid matrix, a 2D grid, and the top left, right? The top left cell actually is the place where there is a knight, and the bottom right place there is a princess. He has to escape, rescue her, rescue the princess, and then he has to actually go through different cells to go to the bottom right, and then each and every cell has some positive and negative numbers or maybe zeros also. So what these number represents are like, each number, if it is negative number, these are the actually health conditions. So if it is a negative number, the knight's health is going to be deteriorated by that number. So if the knight's uh, health condition goes to zero or negative, it means he cannot go further. So he's dead and the game is ended over that. So, but if it is positive, he gains health, and then he can use that health and reach the next cell. And the way he traverses is he can only traverse two directions. One is the downside and the other is to the rightward direction. These are the only two ways he can actually traverse this two grid array. And then what we need to find out is we need to find out an optimal path wherein he can reach the bottom right cell, and we need to find out actually what is the maximum health points it's required for him to sorry, the minimum health points are required to reach the bottom right. Okay, so this is what the whole problem statement talks about. Okay, so in this case, if he has this array about like this, what is described in the example over here, like it starts from -2, -3, 3, -5, -10, 1, and all those things. And this is the top left, which is which starts with -2. So even it says the first cell, the top left or bottom right, also can have numbers. Here it has numbers like -2. So immediately when he comes here, his health is deteriorated by -2. And similarly, when he goes in the last one also, it will be going down by 5. So any cell can have any value. And the optimal path in this case is like here, the -2, -3, 3, 1, and -5. So if we go through this path, we can find, the minimum conditions, health conditions required for the knight to start with has to be 7. So if he has 7, actually he comes here is -2, he'll be having here 5. Then he goes to the right side, which is -3 here. 5 minus 3 will be 2. So he still can move ahead with 2. So 2 plus 3 will be 5, and 5 plus 1 will be 6. And so when he drops over here, 6 minus 5 will be 1. So at least he has to have health of 1. Health of, so if he goes below 0, then it means it's an end of that. So this is an optimal path. Therefore, this is an optimal path. If you go via other paths also, it can happen, but they will need more health points. So here it's 7 with the minimum of 7 health points, he can reach very easily. Okay. So the way I actually, okay, there are many ways to do this problem, the DP way and all the stuff. But I thought actually maybe an easy way to do a sort of a DP only, but using DFS. Okay. Because here we don't have much things to do, because we have only 2 traverses, one going downwards and one going rightward. So if I start from the first cell, even top left, okay, so I have only 2 options, either come to -5 or come to this, the right side is -3. And then I need to find out which is the minimum of this, and then actually subtract that from this guy. So this is the way I can find the path. So in order for come to -3 here, actually I can again go to -10 and then 3. These are the only 2 options. Similarly, I'll have to go for getting values from -10. I'll have to go to this 30 or this 1. Okay, so this is the way I'll have to traverse. So what I was thinking, if I start from here, every time I have to go to the last, to the next one, and at the end I have to always come to the bottom right? So this is the actually should be the starting point if I go for the DFS way.
I think
Santosh, I have one more thing. If we follow the path, I have a 7, -2, 5, and then instead of -3, I choose -5. And then it will become 0, and then I choose 10.
No, if you are 0, you are dead. You can't move ahead.
Oh,
You need at
okay.
least 1.
Okay, got it.
Yeah.
I think DP will also go the same way only. Like we'll choose which of the -3 or -5 is minimum between these two, and depending to the,
DP actually the bottoms up approach is almost similar. Yeah.
Similar to DP,
Yeah. So, but I'm just, the way I thought was using a DFS. I thought of a top-down approach, but then I'll show you how the bottom-up approach also is implemented. But the way I thought of, that is what I'm trying to explain. Because I thought the DFS is very easy. Just I have only 2 positions to go, right? The downward and the right side.
Rightward.
Yeah.
Exactly.
So it is
what is the dimension of the matrix?
It can be anything. It can be.
It's a 2D because that, think about that, what are your variables here? So row and column.
Yeah, that's true. But it can be of any value. That is what I think. It might not be the same 3, 3. I'm not sure. That's not mentioned there though.
M cross N. It's
M
written.
cross N. Yes.
Yeah, it's M cross N. So yeah.
It can be
rectangular matrix. Yeah.
So if this is the matrix, what I was thinking the way is, all these values beyond any of these, what do you say?
So Santosh, in your DFS, you are saying that you calculated all the path and then you pick the minimum from there?
Well, actually, I did. Well, I was going through each of them, so I did not calculate them, but eventually it comes to that, right? So somewhere I have to do what you say, memorization also. So use the same approach, a top-down approach. Okay. So the way I started was I created an array. Here it was 3 by 3. So I had to create an array of 4 by 4. Okay. And I initialized all of these values as int max. Okay. And because, these are the only values. Okay. The one which I say int, they are the int max. So the last column and the last row is initialized to int max. Okay. So the way, why I'm saying this is because I would always start with, even if the knight starts from the top left, he will always come to the lowest one, the bottom right. Actually, and find this value first and then go up, right? Even if it is DFS top down or bottom up, both things will do the same thing in this case. So for that, even if I say if this is INF, okay, so int max, the first value for the one, because this value, I have to calculate this value. So I need to go either to the right side or to the bottom side. So for them actually to be, to start with the base condition, I'll have to set this value as 1 because that is the minimum required health condition, right? So even if I go year or year, I need to set either of them as a 1. And so I just take the minimum of both of them. So it is going to be 1. And so 1 minus 5 in this case will be 1 minus of minus 5 will be 6. Okay. So now I have the value over here, which is 6. Okay. Sorry, this was minus 5, right? Yeah, minus 5. And so this was the value over here. This is a 6 here. And then actually I go, if it is a DFS, it can come any path. And then actually this is 1 minus, now this is the 6 value. So if I go to the 30th, so I can compare this INF, that is int max, with this 6, because it can go downward or it can go to the right side. So INF is the int max and this is a 6. So which is the minimum here? It is 6. So 6 minus 30 here will be minus 24. So when it is minus value, I just make it 1 because it's no use of that minus value, right? So I just make this value here as minus 1, okay, for my next calculation. And then I come here and then for the 10th, actually I have this value INF and this is 1. So both of them, this one and this value 1, the minimum is 1, and then I take this 1 minus 10 will be minus 9. So it will remain again 1. Okay. So this is the way I keep on calculating, and when I come to this position, okay, I get the minimum value. Okay, so the way it comes for each and every one will be, okay, so I'll have to calculate for each and everything, but for this first one, I get this as 6, right? Okay, I messed up with the whole thing. Okay, 6, and here this is 6 and I and 1. So this will be 5. This will be 5, and then I come here. So this guy will be 2, right? And this guy will be 5. And this guy will be 7 in this case. Okay, so if I come for the other values, this is 5, this will be 11. And this value comes to 6. Okay. So from here 6 and this 5, right? So 5 is minimum. So if I would have taken 6 from this side, so 6 minus of minus 2 will be 8, and here actually 5 of minus 2 is 7. So therefore this is the minimum path. Okay, any questions on this?
Why can you explain again why you initialize the initialize you1 for the first value, like on line 14?
On the 14th line, the first value, right? 1.
Yeah.
So actually I told you, right, you need at least 1 health point for it to survive. So the knight can survive only with the minimum health point is 1. So he goes beyond 1, he is dead. Okay. So I just take the minimum value because I have to find the minimum path, right? The optimal minimum path. So I need the minimum health points for the knight. So I start with the minimum value, and therefore the knight, if he is at the last point here in the -1, okay, so he can either go to the right side or he can go to the bottom side, right? So these are the only 2 places he can go. Correct. So I set these values to 1. If I would have set to infinite, then it would be too much, right? But then I would not have been able to get the minimum health points, correct? So therefore I set it to minus just 1 for both of them. Either way, it is going to be the same. Even if I set this 1 also, it's fine. I can just make this into max, or this, I can make this 1 and into max. But I take the minimum of both of them, it's going to be 1 again, right? So therefore I take that 1 and then I subtract with this minus 5. So 1 of minus 5 is equal to plus 5, right? So 1 plus 5 will be 6, and therefore the value comes over here as 6.
What does it mean when you subtract it? I mean,
well, okay, if you are going to do a path, right, you are trying to find a minimum path over here, right? So this is your path, like you're going from here, here, here. So every time you need to find what is the value going to come here. Okay, so how you are going to find a minimum value path? First, each and every cell you need to find what is the minimum health point you need for that knight to survive in that particular cell. So in this cell for the knight, I require 6 points at least. Even if you look at this value, it is minus 5, right? So it is minus 5, and then if you have 6 points, you will have 1. So then your knight can survive in this value at this location, correct? So if you go through each and every cell, okay, do the same math, then you can find out what is the minimum health point required for the knight to be there at that particular cell in order to survive. So, and then if you come to the last cell and then again look at its right and the downside, you can find out which is the minimum value, and then actually you can subtract that, take that minimum value and then subtract the one which is at the current position, current cell. So then you get the minimum health points. So therefore you have to subtract them. You got it? Like,
yeah.
In this case, if it is, yeah. So that is the way the whole thing is. You just go, because that is what the problem statement says. The knight can only traverse at the downward side or the right side. And it's slightly easier for us also to imagine that way. And the way I did was the DFS approach, because even I say it's a DFS, but it is again a bottom up approach though.
Yeah.
Yep.
Sorry, top down approach. I'm sorry. Yeah.
Sorry, top
Top
down.
down, yeah.
Top down, yeah. So, okay, so this is the DFS approach, and this is our entry function. So this entry function actually I have. This is the row columns I just calculated, and then this is the DFS function, and I'm passing these two parameters as a starting point because it's the 0th location. So x is 0 and y is 0, and then go on this the DFS here. If I start from here, so these are the base conditions. Okay, sorry. Okay, so the implementation is very easy. So these only the base conditions are to be very chosen very properly, and you have to understand. So the way you asked, like Leon about 1. So this is the base condition. If I come to the cell when I'm at the last cell, okay. So this side is if I have the rows, means x is equal to the value of rows or minus columns minus 1. Okay, so it means I am at this location, right? Yeah. So I'm just below. This is for the below location. So if I'm at the below position, or I'm at the rightwards at the very end of the last where the princess is, so I need to return 1. That is the only one base condition which is important. And the second, if I cross either of the rows and columns maximum, I just return into max. Okay, and this is just a memo and cache. And here is the DFS, very simple implementation. Like you just have to find the minimum and take again 2 DFS of traversing. One is going downwards, just increment x by 1, and one going rightward, just increment y by 1. That's all. And then when you are done with this, you get the minimum value, which is the path, what I was talking about. And then using this minimum value, you subtract the value, which is the current value at that dungeon cell. Okay. So subtract that value from path, and then you actually store that in the memo. But if this value is going to be negative, it is useless to store that value. So make it 1 and just store that value. So because you need at least 1, you don't need, if there is a negative, then it means we are done. So we have to have at least some value there, positive value. So that is 1. And if you look at the DFS approach without the memo, it will be just the same thing. Keep on actually going and just have this maximum path minus dungeon value, and then you set it to 1 if it is negative, or else you just set the same value. And that's what the implementation is. And if you look at the bottoms up approach also, it is almost the same way. So we have this array, 2D array of rows and columns, and then setting this value to the intermax, each and every value first. And then the last 2 values that I was discussing here, they are set to 1, 1, because you need a 1 as a health point. And then go start with the very last value where the princess is, that is R minus 1 and the column minus 1, and just come from the last point, that is the bottom right, and traverse to the top left. And here you again find what is the minimum value. And this is again the same thing, like you actually, you take the DP cell of this value of the downwards one, and one is the rightwards one, find the minimum of them, and then actually you subtract that from the current dungeon cell. So you then get a minimum value over here, and then you actually store it in the DP array. And the top left array, top left element of the dungeon cell will be your answer, because you are actually iterating and traversing from the downside, bottom right side. Okay, so the implementation looks very easy, but the problem statement and coming to this implementation slightly needs more thinking.
I have a question.
Yep.
You set the last row and the last column to a maximum integer. Why you said that a warrior here? I'm confused a little.
Oh yeah, actually the last row, it's not only the last row, each and every row and column should be initialized to the int max actually. Yeah, the whole array is supposed to be initialized to int max. Okay. And then I actually only set these 2 values, the 2 base conditions for to be 1. Okay. So now why I'm setting these 2 base conditions to 1, because at the position where the princess is, I need to find the value of that cells first, right? Because from I'm actually coming from the bottom right side. So in order to get the value at the where princess is, I need to first set its right and its downwards cell to 1, because that is what the minimum health point is required for the knight to survive, right? So if I set those 2 values to 1, then I can calculate the cell value at where the princess is, which is the last point, and what health points are required for the knight to survive. Got it?
Yeah. Thank you.
Why don't you do the top left to bottom right? Is that I want to know like what your thought process?
You mean to say I should start from the top right and then come to the bottom right?
No, top left.
So top left and then come to the bottom right, right?
Yeah.
Yeah, actually, I was also thinking of the same way, but first for me it took very what do you say? I was more inclined to do with the top-down approach, the DFS approach. I actually did that first, without a memoization. So I actually went in TLE for other solutions, but it worked with the memoization portion, right? So then when I look for the solution also, what these people have explained over here, they also are doing it the same way. And the way I think it makes more sense, because in order to calculate any value, uh, first I have to always get the value for the where princess is first, because the bottom right, getting the bottom right value will be a building block for me to actually get the other values, because that is the base value I need to get. Because if I start from the top, I don't have an access actually to go to the other cells, right? Because I can only traverse the downward side or the right side. Okay, for the top side, if I start from the top side, actually I should have access to go to the top and the left side of a cell, right? Then only I can actually come up with the optimal solution in the case of that. But here it is specifically saying the knight can only go down and to the right side. And so I thought this makes more sense what they are doing it.
कौन सा टाइम बताएगा भैया आपको?
Yeah, I mean, bottom right cell is the only cell for which we know what should be what is the value, minimum value.
Right, right.
But let's say, suppose if we do brute force and we do that first search, we explore every path, and then we get the minimum one.
Yeah.
That can be do from the top down, right?
Yeah.
I mean, from the start to the end.
Yeah, so depth first search also, that is what I'm trying to explain here when I did for this top-down approach. It is a DFS approach, and it just shows the memoization, because I used the memoization later on, but I was doing exactly the way you thought of, Leon. I'm going through the DFS approach.
Yeah,
But
but
even if you go to the DFS approach, it comes to the same thing. You have to you have to go to the last cell, that is the bottom right, get the values from there and recurse back again, right?
I don't think so. I mean, we can start from the top left cell and get the solution.
No, I don't think so. Yeah.
Even in brute force, that will not work.
No, it won't. You can start, but still you have to go to the last cell, and then you have to build that cell first, and then actually keep on coming up, and then you will get the top left cell value.
Yeah, exactly. Because it might be possible that the some intermediate cell may have really high positive value, and that will not tell you that what should be the initial value based on that.
Yeah, that also a good one. Yeah.
Yeah, I would like to add here that as Praveen and Santosh was saying, that we have one extra information when we go from bottom to top, that at every position we know exactly the minimum health we need to have, right? That you cannot get an idea when you go from top to bottom, because things in future will affect your things in past, basically, because somewhere maybe you will get 30 health in future. So whatever calculation you have made while you are standing at say like -5 or 10, which is on the last row first column, that may be wrong because you don't know what is coming in future. So that is one reason. But if you still want to do that, there could be one idea, like you start from the first one and you can binary search the answer here. Like binary search, why? Because okay, you know that this is again going to be a monotonically increasing function of health. If I can survive with health 20, then I should be able to survive on higher health for sure, right? So you can initialize your initial health to be like a very high number, and then you can start cutting down, and you will check whether can I come to -5, and still I can survive in all the possibilities. So if you go and look at the tag of this problem, you will also see there is binary search, by the way.
Oh, interesting. Yeah, that's a good one. Yeah.
How will it work? I mean, it has to be sorted. How will binary search work here?
So you are saying, okay, my initial health is suppose int max.
Okay.
Right?
Yeah.
and then you will say, okay, if it is like my health is that much, then I will say, okay, can I complete, can I go through the like can I reach -5, the last position?
Okay.
You will,
Yeah.
right? You can see you
Okay. Yeah.
cannot.
Yeah. Sure.
Then you will reduce that to half again.
Okay.
And you can continue doing that, and that will lead you to the answer. But then your complexity will become like more, because now your row into column into
Right.
a
Log
log
n.
factor will be there.
Log factor.
Yeah.
Yeah.
So
Got
that
it.
is another
Thanks.
approach you can do.
Okay.
Okay.
Good thing to try. Yeah, thank you.
Yeah.
Yeah.
No problem.
Never thought about that. Okay. So any more questions?
No, I think.
Okay. Okay. So I'll stop the recording and
Yeah.
yeah.
Thanks, Santosh.
Okay. Thank you.
Yeah, thank you.
Thanks,
Thank you.
Santosh.
Thank you. Yeah, thank you. So share.